Welcome back once again, and more examples to follow. Given that sine alpha is equal to -4/5 and alpha lies in the fourth quadrant, find the exact values of cosine alpha over 2. So we can find first fourth quadrant, that means 270 degrees to 360 degrees. So we have alpha over 2, that means we have 135 degrees, and then we have 36 divided by 2, 180 degrees. That means on the second quadrant. This is the fourth quadrant, but this is on the second quadrant. Okay? Yeah. Let's see. On the fourth quadrant, let's see if we can find that. If this is our alpha, then our sine, that is opposite side, that is -4 and 5 here. So this one will be equal to 25, 5 squared minus 16, that is 9, and this will become +3. Okay, let's do it. Cosine alpha over 2 is equal to plus minus the square root of 1 plus cosine alpha. That means 3 over 5 over 2. So we have plus minus the square root of, if we expand the 1, we have 5 plus 3 over 5 over 2. Then we have plus minus the square root of, we have 8 over 10. Plus minus, we have 4 over 5. Plus minus 2 over square root of 5. Plus minus 2. If we multiply both by square root of 5, then we have 2 square root of 5 over 5. Oh, sorry, not plus minus anymore. After that we have done that. What will be? Cosine on the second quadrant is negative, so this will become negative. Okay? Next. Compute the exact value of sine 165 without a calculator using a half-angle identity. And, okay, let's see. Sine 165 degrees is the same as sine double that, 330 degrees divided by 2. Because we need to use the half-angle formula. Is equal to, we have plus minus square root of 1 minus cosine theta divided by 2. And we know that sine that's 330, then we have 30 there. If we're talking about 4 degrees, then we have 2 there, square root of 3 there, and then 1 there. Okay? So sine, the opposite side, that is 1/2. Cosine, I should say. Cosine is 1 minus square root of 3 over 2 over 2. We have plus minus square root of, we have 2 minus square root of 3 over 2 over 2. Plus minus the square root of 2 minus square root of 3 over 4. Then we have 2 minus the square root of 3, the square root of that, oh sorry, it's 2. The square root of that divided by 2. But sine 165 degrees is positive on the second quadrant, so we can use the second quadrant, and this is the answer now. We use the positive, I should say. Sorry. Tangent, compute the exact value of tangent 105 and without a calculator using a half angle formula. Okay, let's see if we can solve this. Tangent 105 degrees. If we double that, tangent, it will become 210 degrees divided by 2. Then we have still. Okay, and 210 is 180 plus 30 degrees. Okay, is equal to 210, as you can see. Then we are interested with 30 degrees, and 30 degrees we already did it in our previous example. That is for cosine, then we have square root of 3 divided by 2, and for sine, that is 1/2. So if I'm going to look for my tangent now, have formula for tangent, the easiest that I can use is this one. Okay, why? Because if I'm going to use the first one, this one, then I will be dealing with a lot of squares. If I'm going to use this, then I will be dealing with squares in my denominator, sorry. So I'm going to use our 1 minus cosine 210 degrees divided by sine 210 degrees. Okay, 210 is in the third degree, so we know that cosine 210 degrees is negative square root of 3 divided by 2. They are screaming outside. And then we have sine 210 in the third quadrant is negative 1/2. Okay, let's continue. We have, if we expand 1 now, then will become 2, and then plus square root of 3 over 2 multiplied by the reciprocal, negative 2 over 1. Then we have, this will become 1, then we have negative 2 minus square root of 3. And we know that tangent on the second degree is negative, so it's alright to have this as it is. Okay, let's see. Third, find the exact values of cosine x over 2 and cotangent x over 2 without using the calculator if sine x is equal to negative 3/5. And our x is between pi and 3 pi over 2. That means if we have x over 2, our x now is between pi over 2 and 3 pi over 4. Okay, so if we can draw that, we have here now third quadrant, not third degree. We have 5 there, and we have negative 3 there, and this one will become 25 minus 9, then that is 16, and we have negative 4 there. Okay, so we can start with cosine x over 2 is equal to positive negative square root of 1 plus cosine x divided by 2. We have positive negative square root of 1 plus cosine x is, if this is our x, cosine is adjacent, that is negative 4 divided by 5 over 2. And we have plus minus square root of, we have 5 minus 4 over 5 over 2. Then we have plus minus square root of 1/5 multiplied by 1/2. Then we have plus minus square root of 110. And we have cosine in the second quadrant is negative, so we choose negative. And we have 1 over square root of 10, or if we expand it, then we have negative square root of 10 over 10. For our b, we have cotangent x over 2, and that is the same as 1 over tangent x over 2. So we can use which of these. This is complicated, that's alright, that's alright. But we can start with the reciprocal of this one. 1 plus cosine x over sine x. Then we have 1 plus cosine x in the third degree, that is negative 4 over 5 over negative 3/5. Simplify, we have 5 minus 4 over 5 over negative 3/5. This will become 1. Then we have 1/3, which is negative. And cotangent, tangent in the second degree, second quadrant, is negative, so it's also negative for the cotangent. So that's alright. I stay there, and I hope you learned something, and I hope you will watch my next video also. My next video will be solving 3 more examples, and it's all about identities also. And I hope you will be there. Thank you for watching, and have a nice day. See you soon.